Mole concept. Now, before we start studying what is mole concept, let us take an example of the reaction of hydrogen and oxygen to form water. The above reaction indicates that two molecules of hydrogen combines with one molecule of oxygen to form two molecules of water, or 4 atomic mass unit of hydrogen molecule combines with 32 atomic mass unit of oxygen molecule to give 36 atomic mass unit of water molecule. Now we can see that the quantity of the substance can be measured by using mass or the number of molecules. But a chemical reaction indicates directly the number of atoms or molecules taking part in the reaction. Therefore, it is more convenient to refer the quantity of the substance in terms of number of atoms rather than their masses. Now, whenever we see a chemical reaction that is happening, it is very difficult to calculate the mass of all the atoms and then the final mass of the molecules. But it is easy to see the number of atoms and then tell that how many molecules and atoms are reacting. So we generally take in consideration the atomic number and not the atomic mass. So a new unit was introduced, and this new unit is called as a mole. Now what is a mole? Mole is a link between the mass of atoms or molecules and the number of atoms. So we need to have a relation between mass and the number of atoms, and that relationship is called as a mole. The number of particles, that is atoms, molecules or ions, present in 1 mole of any substance is fixed, and this value is 6.022 into 10 raised to 23. Now, how did we find this number? It was derived experimentally by the scientists. Now, this number is also called as Avogadro's constant or Avogadro's number, and it is represented as NO. Why? Because an Italian scientist called as Amedeo Avogadro, he discovered that this is the value of 1 mole of any substance. Now we know that 1 dozen of banana is 12 and 1 gross is 144 numbers. Similarly, 1 mole is equal to 6.022 into 10 raised to 23. The mass of 1 mole of a substance is equal to its relative atomic or molecular mass in grams. Now to get the mass of 1 mole of atom of that element, molar mass, we have to take the same numerical value but change the units from atomic mass unit to grams. Molar mass of an atom is also known as gram atomic mass. Now, for example, we know that the atomic mass of hydrogen is 1 unit. Therefore, its gram atomic mass is 1 gram. Now, 1 unit of hydrogen has only 1 atom of hydrogen and 1 gram has 1 mole of hydrogen. And we know that 1 mole is equal to 6.022 into 10 raised to 23. Now taking another example of oxygen. We know that oxygen atomic mass unit is 16. So in grams, it is going to be 16 grams. So 16 grams is 1 mole. And 1 mole is 6.022 into 10 raised to 23 atoms of oxygen. Let us understand how to calculate the number of moles for 52 grams of helium. Now, number of moles is equal to n. Let us take given mass as small m. Molar mass is capital M. Given number of particles as n, and Avogadro's number of particles as n0, and Avogadro's number of particles as n0. Now the atomic mass of He, that is helium, is 4 units. So in grams, it is going to be 4 grams. To find number of moles, the formula is given mass upon the molar mass. Hence, In short, we can write as a small n is equal to small m upon capital M. So we know that the given mass is 52 grams and the molar mass is 4 grams. So the final answer is 13. So there are 13 moles in 52 grams of helium. Next question is 12.044 into 10 raised to 23 number of helium atoms. We need to find number of moles in it. Now we already know via Avogadro that 1 mole equals to 6.022 into 10 raised to 23. So we need to find the number of moles and the formula is number of moles is equal to given number of particles upon Avogadro's number. Now number of mole is small n, that is equal to number of given particles, which is capital N, upon Avogadro's number, which is N0. So that is equal to, this is the given number of particles. So 12.044 into 10 raised to 23 upon the Avogadro's number is 6.022 into 10 raised to 23. And the answer is 2. So there are 2 moles in 12.044 into 10 raised to 23 number of helium atoms. Next, we need to calculate the mass of 0.5 mole of N2 gas. We know that mass is equal to molar mass into number of moles. So that is equal to small m equals to capital M into N. The molar mass is 28 into number of moles is given as 0.5. So 0.5. The answer is 14 grams. So the mass of 0.5 mole of nitrogen gas is 14 grams. Now we need to find 0.5 moles of N atoms. Now again the same formula, mass is equal to molar mass into number of moles. That is small m equals to capital M into N. So we know that the molar mass of N is 14 into 0.5 mole. That is 7 grams is present in 0.5 mole of N atom. The next is 3.011 into 10 raised to 23 number of N atom. We need to find the mass from this given number. So we already know how to calculate the number of moles. So number of moles that is small n will be calculated by the formula small n equals to capital N upon Avogadro's number, that is N0, and capital N is number of given particles. So the number of given particle is 3.011 into 10 raised to 23 upon Avogadro's constant is 6.022 into 10 raised to 23. The answer is 0.5. But we need to find the number. This is 0.5. We need to find the mass. So 0.5 multiplied by N atoms. We know that the molecular mass of nitrogen is 14. So 14 into 0.5. That is equal to 7 grams. So the mass of 3.011 into 10 raised to 23 is 7 grams. Now similarly we'll be following the same steps for the N2 atoms. Small n equals to capital N upon N0. That is equal to 6.022 into 10 raised to 23 upon the Avogadro's number, which is same 6.022 into 10 raised to 23. So the answer is 1. Now we need to find the mass. So small m is equal to capital M into N. That is equal to the molecular mass of N2 is 28. How is it 28? N2, that is equal to 14 into 2. That is equal to 28. So 28 into small n, which is 1. So the final answer is 28 grams. So the weight of 6.022 into 10 raised to 23 number of N2 molecules will be 28 grams. Next, we need to calculate the number of particles in each of the following. 46 grams of any atom, so we need to find how many number of particles will be present. Now the formula for the number of atom is equal to given mass upon molar mass into Avogadro's number. So in short, we can write it as capital N is equal to small m upon capital M into N0. So this will be the formula that we'll be using. Now we need to find the number of particles, that is N. So capital N equals to given mass is 46 grams. And we know that the mass of any atom is 23 grams into 6.022, that is the Avogadro's number, into 10 raised to 23. So the final answer will be 12.044 into 10 raised to 23. N equals to. So these many particles will be present in 46 grams of any atom. Next, we need to find number of molecules in 8 grams of oxygen molecule. So we already know the formula, that is capital N is equal to small m upon capital M into N0. So the given mass is 8 grams. And we know that the atomic mass of O2 molecule is 32 grams. How 32 grams? Atomic mass of one atom of oxygen is 16 and there are 2 atoms of oxygen. So into 2, that will give me 32 grams. So 8 divided by 32 into the Avogadro's number is 6.022 into 10 raised to 23. So the final answer is 1.50 into 10 raised to 23. So these many particles will be present in 8 grams of oxygen molecule. Now we need to find number of given moles in 0.1 mole of carbon atom. Formula for the number of particle is equal to number of moles of particles into Avogadro's number. Now number of particle is capital N and number of moles is written as small n, and we know that the Avogadro's constant is written as N0. So small n is given as 0.1 mole into Avogadro's number is 6.022 into 10 raised to 23. So the final answer will be 6.022 into 10 raised to 22. So these many particles will be present in 0.1 mole of carbon atom.